Hello everyone, welcome to Scientia Investment channel. I'm here to explore another quantitative techniques useful for investment and trading. In this session, we are going to explore maximum drawdown analysis and the way that we can implement it using Python code. So before delving into the implementation, let's see what is the maximum drawdown in action. We have the values of S&P 500 for over 5 years from 2020 to 2025. As you can see, the price has had a significant fluctuations, and when we want to invest in such an asset, we should consider the worst case scenario. The worst case scenario is that we buy the asset at this point with the hope of increasing value, but all of a sudden it plunge to the significant lower value. For gauging this risk, we always use maximum drawdown. So if we draw the maximum drawdown for S&P 500, you can see all the drawdown here. The interesting is that when we look at the value chart, you might believe that this drawdown is the most significant one and the biggest one. However, the drawdown analysis shows that the significant one is here right after the corner. Having said that, let's review steps that we need to calculate maximum drawdown using math. So at the first step, we have the price data from P1 to PT. So next step, we need to calculate running maximum, or some people call it as a cumulative maximum. The definition of that is in a specific period of time from beginning till the end current point, we pick the maximum one. So after that, we can calculate the drawdown, which is derived by dividing the difference of current value and the running maximum by the maximum value to drawdown. And as you can see, the drawdown would be the negative value, because always the running maximum is higher or equal to current value or price. So because of that, the minimum of this value can be considered as the maximum drawdown. Okay, so now we know all the nitty-gritty of maximum drawdown analysis from theoretical perspective. So let's get into the Python code implementation. Okay, now we need to roll up our sleeves and start coding. First thing first, we need to import a couple of libraries. I consider Yahoo Finance, Pandas, and Matplotlib for visualization. So let's start it. Okay. and then we run this block to make sure that our code is executable. Here we go. We can go to the next block to fetch the S&P 500 data from Yahoo Finance. First, we need to define the ticker. As you know, Yahoo Finance, no S&P 500 as power sign GSP C. Okay, and then I create a data frame equal to Yahoo Finance that download, and I need to pass the ticker start, which is equal to the 1st of January 2020. And the end, which is 1st of January 2025. We go. And the next part is to eliminating the multi-indexing of the data frame which contain the Yahoo Finance data. So let me have the code and then go through it. Okay, this is the list comprehension in the Python, which let us run the loop, and if inside the data series. So for making it the super clear, it's better to complete this code, and then we can discuss the result. So here I use the data info to be able to see the summary of the data in the data frame. And finally, I will have the data heads to see the 5 first rows of data. And the default is a 5, but here we can choose a 10 to have a first 10 rows. Okay. Here we go. We execute. Oops. It seems that we have a syntax error. Yes, I used the wrong brackets. So oh, we have the extra s here. So let's correct it, and here we go. We have the first 10, 10 rows of the data here, and let's disable this code to see what would happen. So I changed into the comment and then execute the code again. Okay, you see that here we have the multiple index. So we have two rows of index, which in most of the time it creates the problems when we want to process the data in the future steps. So we used this code here to get rid of these extra indexing here. And the logic of that is for each column it conduct the if condition if there is the multiple indexing of the call or and a tuple one. It's eliminate the second part and just retrieve the first element, which is call 0. This is as easy as you can see. So I run this again to make sure that we have the tidy data. So I consider as so in the next step, we start implementing the formulas that we have just reviewed in the slide. Firstly, I use very slide data cleansing here, but in the real project, we need to have a more comprehensive data cleansing. But here we only try to avoid the NA value by using the forward filling method of pandas. As you know, we are going to process the close column. So this code explore the all values in these columns and fill any NA or missing value by the next record in this column. After that, we need to calculate the running maximum. So I need to use it for a close value. And then calculate the drawdown and assign it to the new column. Actually, here I'm adding a new column to the data frame and call it drawdown. Oh, sorry, I forgot to add another column here to capture the running maximum. So I call the running max, and here we can divide it. If you remember, for calculating the drawdown, we divided the difference of close value of from the running max by the running max. But as you can see here, we have the close value divided by running max minus 1. Actually, this is the simplified of that formula. I believe that is very easy to understand if you try to drive these from the formula that we reviewed in the slide. Easily you can understand and observe the concept behind that. However, if you find it challenging, please put it in the comments, and then we can discuss it in more detail. And finally, we need to find the maximum drawdown. And then we print the values. Perfect. As you can see, we have we are printing the string value, but we used the f string to embed some variable into the string inside the curly brackets. So when we run it, it can gives us the result. Okay, we can see that the maximum drawdown for S&P 500 over the 5 years is the minus of 33.92%. It means that in the worst case scenario, it can decrease the value up to 30.92%. So the next step is visualizing our result to make it easier for everyone to understand and observe what the maximum drawdown is showing us. Okay, let's go for the most exciting part, which is visualization. First thing first, we plot the price chart. We use matplotlib.pyplot as a PLT, but before that we need to declare the size of frame that we are using. We use fixed size equal to 10 and 6. Then use plt.plot for plotting the price chart easily, and we need the X and Y data. We are plotting a two-dimensional the chart. You can have a date on the x-axis and the value on the y-axis. So easily we have a x as data index, which is date, and y as a date, the column, the close column. Also, we label it as a close value. I use plt.grid to have a grid on the chart for the better clarity, and then add title and legends. Okay. And then I label X and Y axis. The X is date, and Y is a value. and after that I have a legend to enhance the chart clarity, and finally I need to use plt.show to make sure that all the charts element will be visible. Otherwise it doesn't show the chart and its elements. Okay, this is the first chart for the price value. The second chart is for drawdown. And so as these two chunk of codes are very similar, I pause the video here to save time. I put the related code, and then I describe you the difference between two chunks of code. Okay, as you can see, these two pieces of code are very similar. The difference is that in the top one, we have a data index and the close value, but in the bottom one, instead of a close value, we have the drawdown. And also we added the new line of code to fill between the access and the value to make it more appealing and visualize it in a better way. So it's easy to follow code. You can see fill between, it totally makes sense that we need to fill between two values of data index and data drawdown, and we choose the color equal to red or any arbitrary colors that you use, and I use the alpha parameters for making it a bit transparent to make it more tidy and appealing. So and also you can use other parameters. For example, if you choose the alpha equal to 0, it would be totally transparent, and if you use it alpha equal to 1, it would be the solid and not transparent. So let's start this block of code. Okay, we have the brilliant charts. But it seems that, okay, we have an error here. Okay, let's have a look to see what is the problem. It seems that the drawdown is not defined, so let's have a look. Okay, it seems that I used the drawdown with the capital D in the middle, but here I used this drawdown with the small d, so it should be easy to fix. Let's try it again. We have another drawdown with the small d. Okay, the easiest way to find the easiest way to find what is wrong with the drawdown is using Control F to find all the drawdown in our codes. Let's copy and paste it. Okay, I found that. Now it should be fixed. Let's try it again. Let's try it one more time. And here we go. We have exactly what we illustrated in the presentation slides. So you can compare the value chart with the drawdown and visualize your risk in investment in S&P 500. Okay, I hope it was helpful for you. Feel free to share your ideas how we can use the drawdown analysis in the risk management of our investments. And I hope to catch up soon again with you.